Hello, in this video I am showing how to solve the 1998 AP Chemistry Free Response Question 8 by College Board. For Part A, it asks us to write a balanced net ionic equation for the spontaneous reaction that occurs as the cell operates and determine the cell voltage for the system that the picture shows. For this, we first need to find out whether CD or AG is reducing by using a cell potential chart like the one I am showing. When you look at the cell potential chart, you can see that for CD, the half cell potential is more negative than the AG half cell, which means that this reaction, CD, is being oxidized. So, to make the net ionic equation, we should first make the half reactions. Since AG is being reduced, it is becoming more negative, so its half reaction looks like this. And since CD is being oxidized, it is becoming more positive, so it looks like this. Now we have to combine the two half reactions. We must balance out the electrons, so we have to go back and double AG, and then we can combine them. Now that AG has been doubled, we can cancel out the electrons and combine the two reactions. This is what the finished net ionic equation should look like. Now that we have the net ionic equation, we have to find the cell voltage, which we can find by using the cell potential chart. By using the cell potential chart, we find that AG reducing has a cell potential of 0.8, and then we also find that CD reducing has a cell potential of negative 0.4. But since we are going to be oxidizing CD, we have to switch the sign and make it positive. By adding together the two numbers that we just found using the cell potential chart, we find that we get an answer of 1.2 volts for our cell voltage. In Part B, we are asked in which direction do the anions flow in the salt bridge as the cell operates, and to justify our answer. The anions flow towards the CD half cell as I show in the picture, since it is the anode which undergoes oxidation. In more detail, the CD creates CD plus 2 ions, which attract anions to bond with them to balance out the more positive charge, which it gained from losing its electrons to the cathode Ag. In Part C, we are asked if 10 milliliters of 3 molar AgNO3 solution is added to the half cell on the right, what will happen to the cell voltage, and to explain. As the concentration of the reactants increase, so does the cell voltage. Therefore, since AgNO3 is equivalent to Ag+, which is reactant in our reaction, the cell voltage shall increase. In Part D, we are asked if 1 gram of solid NaCl is added to each half cell, what will happen to the cell voltage, and to explain. Using the same theory from question 3, cell voltage would decrease because the Cl- from NaCl would react and form a precipitate with Ag+ from AgNO3. Lessening the concentration of Ag+ to react in the half cell, thus making less cell voltage. In question E, we are asked if 20 milliliters of distilled water is added to both half cells, the cell voltage decreases. Why? This uses the same theory as in questions C and D. It is because the concentration of Ag+ and CD plus 2, the reactants, is lessened. Therefore, that makes the cell voltage decrease. This concludes this video. I hope that any questions you might have had were answered. Thank you for watching.